Here's a fourth particle equilibrium problem. But this one I'm going to end up needing to solve a 2 by 2. So I have a 70 kilogram mass times 9.81 is 686.7 newtons. I have a tension TAC, 30 degrees from horizontal. And I have a tension TAB that's 50 degrees from horizontal. For my x equation, if I take to the right to be positive, I have negative cosine 50 TAB plus cosine 30 TAC is equal to 0. In the y direction, if I take up to be positive, I have TAB sine 50 plus TAC sine 30, which is 0.5, minus 686.7 is equal to 0. So now you have to solve a 2 by 2 system of equations. You could subtract one equation from another. You can do some algebraic manipulations to get that. But it's just way easier to solve the matrix. And you should know, not only know how to solve a matrix on your calculator, it should be just automatic for you. It should be no problem whatsoever. So what we're going to do is we're going to convert this guy to a matrix form. The negative cosine 50 is negative 0.6428. The cosine 30 is 0.866. The sine 50 is 0.766. The sine 30 is 0.5. My right-hand side is 0, and I bring this negative guy over here, and he is a positive 686.7. So this is a matrix representation of this system of equations. And it's the same system. So by matrix algebra, this guy times this guy plus this guy times this guy is equal to this. This guy times this guy plus this guy times this guy is equal to that. That's how you do the matrix algebra. So this is exactly the same thing as this. But because we've written it in matrix form, now we can use matrix methods to solve the system of equations, which is super easy on your calculator. And so on your on your TI nSpire, I'm going to go to simult. And you can get there through a menu. You can go menu, algebra, and whatever and get there. But I'm actually going to use this catalog key. And then I'm going to click on S. And I'm going to scroll down and find the simult function, simult for simultaneous equations. And I'm going to set up this coefficient matrix. And so I'm going to hit this. This is a template key. I'm going to hit this guy. And there's a 2 by 2 here. So enter. There's my 2 by 2. And then I'm going to hit a comma. I'll go back to the template, and this is my right-hand vector, column vector. Enter. Okay, so now I have the simult set up this way, where I basically have the matrix, coefficient matrix here, comma. I have the right-hand column vector here, and in each of these terms, each of these placeholders, I'm going to plug in these numbers. So this guy goes here, this guy goes here, this guy goes there, and so on. Let's do that. So I just use my cursors to navigate. And I get here, this is negative 0.6428. And then next is 0.866 down. And here is 0.766. And here is 0.5. Skip to the right-hand side to that column vector. I've got 0, skip down, and I have 686.7. Navigate out with my cursor. I just hit enter. And it basically gives me the vector of unknowns. It gives me this unknown vector, and which is basically 603.9 newtons is TAB, and 448.2 is TAC. Can you see how simple that is? How powerful that is? It's just super easy. And In vector math, this is kind of the form, a coefficient matrix A times an unknown vector is equal to a vector B. And so your unknown vector, which is this guy, is equal to A inverse times B. So there's multiple ways your calculator can solve this system, but one of the ways is it basically just takes the inverse of this coefficient matrix, applies it times the right-hand side, and then you get the unknowns. And that's kind of why you enter it this way. It gives you the A, gives you the B, and takes the inverse of this and multiplies times that. You actually can go straight to the simult equation. See, I think you can do that. Where basically simult, and this is true on the TI. So this is on the nSpire, TI, nSpire. But you can also do this on the TI-89. You can go simult, square bracket, and put these guys in. So negative 0.6428, comma, 0.866. To signify you're at the end of the first row, put in a semicolon, which is basically, I guess you have to go to symbols. And there's a semicolon down there. Semicolon. And then you go 0.766, comma, 0.5. Now you're at the end of the matrix, so close it. Put in a comma, left parent, and then you're going to go 0. And now that you're into the first row, put in a semicolon, and then 686.7. Close it, parenthesis. And you can do this on the nSpire, or you can do this on the 89. So this is an option that you have to, but you get the same answer. Future problems, we're going to do this over and over and over again for 2x2s, 3x3s on 3D problems. And later in the class, when we get to three-dimensional rigid body equilibrium, we might solve a 4x4, a 5x5, or even a 6x6 using the same process. So learn this well. It's one of the reasons I encourage you to get a TI nSpire or some other calculator that's vector capable, because the vectors are easy on it, but also the solving systems of equations is something you need to be able to do as well. I'll stop this video here and then I'll work a few more examples as we go. I wrote out how to enter this directly into the simult function instead of using the templates, but let's do this and I'll show you how it works on the TI nSpire. I don't think I've ever actually done this on the TI nSpire. This is how you do it, or how I do it on the TI-89. But on the TI nSpire, I've always pretty much done it this way. But just to prove to you that this works, you basically can turn this on, catalog, simult, and then we're going to go square brackets, and then we're going to go negative 0.6428, comma, 0.866. We need a semicolon to signify the end of the first row. So we go control symbol, and semicolon is selected, enter. Then 0.766, comma, 0.5. And that's this guy. Then we're going to step out of the square bracket, and then we're going to go comma, and then we need another square bracket. Then we're going to go 0. Control symbol, we need the semicolon for the end of that row, enter. And then 686.7, step out of the bracket, enter. And notice it displays it actually this way, but it gives you the answer of 603.9 and 448.2 newtons. And so if you know what you're doing, this is relatively fast too. rather than pulling up the templates. And so it gives you the options anyway.